Hi everyone, it's Lucia Page-Harley, and today I'm going to talk through a machine learning project I did where I predicted London bike rentals. So how many bikes are rented on a given day in London? Millions of people use rental bikes around the world to commute and for recreation. And understanding the numbers of bikes rented is crucial for bike companies to allocate resources, prioritize their advertisement, and prepare for big events. But since many external variables like the date and the weather drive how many bikes are rented, it's hard to predict exactly how many will be rented on a given day. Luckily for us, a dataset was compiled incorporating a large number of potentially useful features surrounding bike rentals in London. So in this project, I will build a machine learning model to predict the number of bikes rented in London on a given day. So if we take a look at the dataset, we have tabular data that's been pre-aggregated from three sources. So there's the bike data, as in how many bikes were rented on a day. There's various information about the weather, and there are bank holidays, which are really important in London because no one goes to work. There's about 17,400 rows and 10 columns, which include the date, the temperature, the feels like temperature, humidity, wind speed, weather code, which is like rainy, cloudy, etc., whether or not it's a holiday or a weekend, the season of the year, and the number of bikes rented on that day. And the data is fully clean and there's no missing values. So the research question: can a linear or tree-based regression model be used to predict the number of bikes rented on a given day in London? So this is just an outline of my process, and I'll go through the steps a little bit afterwards. But the first thing is that I wanted to keep all data transformations inside scikit-learn pipeline objects so that no matter what got passed in, with it being the training set, validation set, or test set, all data transformations would be done evenly to everything and nothing would get lost and it would all be streamlined. In terms of pre-processing, I will split dates into hour, day of week, day of month, and month because those carry more information than just a raw date. I'll impute missing values, even though there aren't any in the test set or in the training set, just in case a user inputs a test feature vector and it has a missing value. I want to be able to just handle that. Encode categorical variables and standardize my target variable. I'll use randomized search CV to iterate through different tree and linear models, and then I'll evaluate using validation, R-squared, MAE, and RMSE. And then I'll choose the best model and run on the test set. So some highlights from pre-processing. I built a custom function transformer to split dates, which was a little bit tough given the way that the scikit-learn pipeline objects are structured, because everything comes out as a NumPy array and it's hard to keep track of the new columns that you're adding. So I built that function transformer to split the dates into 4 new columns and kind of keep track of them through the rest of the pipeline. On the right, you can see that our target variable is really skewed, and the law of linear regression, thy target variable must always be normally distributed. So I threw that into a normalization step as well. I built separate pipelines for nominal, ordinal, and numerical features. And then I assigned a dummy estimator to the last step of the pipeline so that during randomized search, I could pass in different models and different sets of hyperparameters completely automated. So of the models that I ran, here are the highlights. I have a baseline linear regression, which I ran before doing any pre-processing, which gave an R-squared of about 25%, which is really bad. It's about 25% better than just a plain model that predicts the mean. And it means that about 25% of the variability in the target is explained by the model. And the MAE is in the units of Y. So it says for every prediction on average, they're about 682 bikes off in guessing the true number. So after running ridge regression, or after running a bunch of regression models, the best regression was a ridge regression. And this included all the pre-processing, and the best R-squared was 72%, which was immediately much better. And the MAE was only about 400 bikes off from 682 bikes off. And tree models really took the cake. The best one was a gradient boosting regressor with a really high validation R-squared of 96% and an MAE of only about 111 bikes off on any given prediction. So if you take a look at feature importance, the most important features are season, holiday, and weekend, which totally makes sense, especially season, particularly in London, because some seasons are more rainy and gross and people wouldn't want to ride bikes outside. I think holiday and weekend probably also mean that people either use these bikes to commute or not to commute, which I'll go into in a second. So in terms of interpretation, the best model was a gradient boosting regression tree, which primarily chose weather and date columns as split points. And the feature importance doesn't say whether, you know, spring people rented more bikes or less bikes. They just said that this certain season is the most important decision factor. So I think my best guess is that people use the bikes to commute, weighted by whether or not it's nice out. And in terms of business context, rental companies could increase or reduce, depending on which direction it is, available bikes on weekends and holidays and during the winter months. And they could also contextualize their own advertisement based on feature importance. So limitations of this model include the scope of the models I chose. I tried to keep it within kind of simple baseline scikit-learn models, and the features that were included in the data set. So there was nothing about users, about their demographics. And I think in particular, a good future direction for this project would be to include information about who is renting which bike, and you could cluster users based on which types of people, whether they're working, whether it's for recreation, for some other reason, who are renting bikes at different times, and prioritize advertisement for that. So I also built a small app that's hosted locally where you can just sort of visualize the process of the model, and you can plug in any of the 9 features. You can put in whatever value you want, and it spits out a prediction for you. So if you check out app.py in the GitHub repository, you can just download this and host it locally. Thank you so much for listening.